So PapyGame, briefly speaking, is an extension of the Papyrus modeling tool environment. It has been extended with the gamification component. So this means that while modeling, you can play a certain type of game that the teacher can define a priori and can assign to the students for the learning purpose. So this means that in this demo, I will show you how using the UML class diagrams, the teacher can assign assignments, and the players can compete and play solving the UML class diagram problem. So this is the classical Eclipse environment where we have studied Papyrus modeling tool and PapyGame. So you can briefly open the view of the PapyGame plugin that we have implemented. So you can start in some way the view of the game. Of course, you can insert your username for the demo purpose. We call it demo February 23, and we define a password for this. To create a user, we can confirm the password in such a way that the user can create the account and can remember the login values to play also in different period of time. So this means that the student can also start the game, but it can also jump from the game to another task and come back to the game later. So when the student enter the PapyGame environment, you can see the dashboard. So dashboard is the assignment description, in this case graphically. So you see that the game is composed by 5 levels. This is an assignment 3A that is specific for the classroom. For example, in a software engineering course, the teacher can describe this game with a label. And so we have the username of the player and the accumulated points that, of course, they start from 0 when the player starts to play with the tool. So we have the 5 levels. In this case, we have also a story related to the game. So the teacher can assign, in this case, a narrative, to the level of a specific game, from the green belt, for example, to the black. And each layer has a specific exercise that the students must solve to evolve from one level to another one. So when the student is ready, it can click to the first level. So if we click. Okay, this is the demo, the demo time. So let's see what's happening. Sorry, I need to restart a little bit. Just a moment. Just a moment. Start. Okay, so we can retry. Let's see if now it's working. Okay, yes. Okay. So when the first level is started, so the player can see the description of the specific level, so the exercise that must be solved, and the general rule of the game. In this case, it's a flow game, so each level requires the definition of a certain type of element to model a detailed UML class diagram for the assigned system. In this case, we are speaking about a food ordering system, and the player must model a UML class diagram describing the system, and for this specific level, the level must include the definition of at least 5 classes. When the player is ready, the player can start the level, and it can define using the Papyrus environment, can start to model the system. So in this case, we can define the classes. For example, we have a general user. We can have a cook, for example. We can have a final customer for the system. We can define, for example, a delivery person, and we can have a food item, for example, for the system. Can define the general order. Okay? And for the first level, for example, we have done. So when the player has defined at least 5 classes, can submit the model to the evaluator. So in this case, a PapyGame is calculating the correctness of the model with respect to the rules and accumulate points. So we have gamification rules assigned to the specific level. And the player can resume the dashboard, so can come back to the game and continue with the second level. As you can see, the first level is very basic, and so we're growing also in terms of difficulty from one level to another one. So we need to reach the blue belt, and for this we have the second exercise. So the player must continue modeling the food ordering system, and for this, oh my God, sorry. And for this level, the player must add at least one abstract class and one generalization relationship. So this means that the student can continue. So we can have the abstract class like the menu of the food ordering system. We need to specify that this class is abstract. So using Papyrus, we can set this the abstract class. So we have an abstract class. We can define also the generalization. For example, we have a pizza menu, for example, and can have a promo menu. Okay, and using the palette of Papyrus, we can also define the generalization links. So we can connect the two classes with the generalization that we can see here somewhere from the palette. Okay, we can select this and define the generalization. At the same time, we can define also another generalization. So at this level, the student is learning how to use the generalization and how to define abstract classes. So we come back to the PapyGame. We submit the model. So the system check these rules that has been defined, and the player can have new points and new experience points, counting also the seconds consumed to play the game and to model the specific diagram. So we can come back to the dashboard. So we go to the third level. That, as you can see, will be a little bit complicated. No, so here at this level, the teacher is requesting that the association between the classes and at least one aggregation or a composition. So this means that we complicate the level of the game. We can see, for example, how to relate the cook to the food item, for example. So we can create a difference relation, for example, an association between the cooking system and the food item. And we can also define the properties. So, for example, we can see that can create the association without a specific direction. Okay, we can also define, for example, the classical multiplicity. So this means that here we need to change the properties to 1 to star. Sorry, to star. To star is correct. Okay. And so we can also change the classifier that we did before, to the association. Okay. And we can okay, say that's one cook. So it means that this relation. Sorry. I see another window here. So here we need to put one. So and here we need to put the one, for example. Okay. So, and in this case, the player can also continue submitting the model, but at this time, probably we have our errors because the request done by the teacher has not been implemented correctly by the students, and the player should continue from this level again, and the game will restart from the same level. So this means that we need to restart, and we need to define the model correctly. So in general, the teacher can define the different rules. For example, here we reach a very simple model, but of course we can continue, and you can see also the description here. No, so we need to have an aggregation. So, for example, a food item must be related to the order. Okay? And here we need to say that the relation is an aggregation and not a simple association. So this is the wrong arrow. Let me delete it. We can have also here some generalization, association class, no, association probably is the same, but we need to change the. It depends on the tool. But in this case, so this is the owner aggregation here. Okay, for example here, no. So that we have the order. So one order is composed by more than one item. So we need to change also the multiplicity here. Okay, this is the aggregation. We can come back here, at least one aggregation, and we need to create association between classes. For example, as we said before, we can associate the cookie to the food item. So when we haven't done this, probably now we have the correct model. Let's see. No, okay, we need to change something. No, it is correct. As you can see, probably there is some error in the backend, but you can go to the different level, and now you have another exercise. So you have to define attributes with their types for the classes. So this means that now we extend the model, and we can also specify the attributes to the user. For example, the user has a name. Okay, we can associate the name and also the type to the name, like a string. Okay. We can define another attributes like the address of the user. And we can also assign the type. It's a string. And we can also add another, again, because we need to reach at least 5. So we need to have the phone. Also the phone is a string. Okay. This is for the user. We need to reach 5, so we go to the order and we say the status of the order, for example. And the status should be the boolean, for example. Type. Okay. And another type the date, for example, of the order. And also the date is a string for the moment. We can also assign a string. Okay, and now we should check that we have included the 5 attributes with the types. Okay. So, and now we reach the last level, like, that is the last exercise of this project that includes the operation for the classes. Okay, so I don't finalize this. Let's try to submit with errors. So we should receive errors. And I want to share to share the last aspect, that is when the user has finalized the game, can see a leaderboard, so can see what are the points accumulated during the game, and can see also what is the level respect to the other participants. You know, so for example, we can see the demo test, something that I did before, and now we reach this position in the leaderboard with the specific points that have been accumulated with the normal points and the gold coins that are calculated using aspects like the time and the errors done by uh, by by the teacher. So to conclude with some aspects, so in general, PapyGame is composed by these six components. So we have the game dashboard, that where the player can see the games and play with this modeling competition. For example, there is a software modeling tool that is Papyrus in this case, that has been extended with these gamification elements. There is the gamification design framework that we have implemented, that we use to model the game part. So the concept of the points, the rules of the games, and so on and so forth. There is the gamification engine, that is the component that is in charge to consume the action done by the software modeling tool, and use the rules so defined by the gamification design framework to accumulate points and to evolve the status of the player. The game master is a kind of connector that connects the gamification to the model comparator, in the sense to transform all the model artifacts and give these artifacts to the model comparator to compare the modeling done by the player with the constraints defined by the teacher. So I hope that was clear. So let me know if you have question, or you want to know something more on PapyGame. Thanks a lot on your attention.